Good afternoon. It's an honor to have a talk in the ACM MobiSys. Today, I'd like to introduce precise indoor positioning solution and IoT technology for larger scale fleet management and the mobility industry. So this is my talk's contents. The first one is technology. So I'd like to introduce technology and solutions about the PLS, which is polarized sensing. It is precise indoor positioning solution for vehicles. This is a market problem the planet are seeking to solve. As you know, GPS or GNS signals cannot go through the indoor space. So the robots and automotives in the indoor space cannot receive the signal to recognize where it is. So many conventional solutions have tried to solve this problem so far. But these major attacks have a fatal vulnerability like this thing. So, for example, SLAM technology. SLAM is very popular technology, right? So, LiDAR and camera. It can detect the features of the terrain and environments, but it has vulnerability on the dynamic environments. In the tag system, so Amazon used tag system. It can detect the QR code RFID to recognize where it is, but it can be damaged, the physical damage or tags. And third, UWB. UWB is ultra-wideband, is one of the radio frequency signals. So it uses triangulation with ultra-wideband out of signals, but it can be interfered with the other sources. And last one is mobile IP technology, geomagnetics, Bluetooth, with Wi-Fi. Yeah, it can operate on mobile phone, but it can also have interference problems. So those conventional solutions can operate the indoor space with a lot of people. So this is the most vulnerable environment for R. So people, the space with a lot of people is the most vulnerable environment for those solutions. We can solve this problem. So this is our solutions. PLS, polarized sensing. So our solution is comprised of two parts. First one is transmitter, which is POLA. So POLA is comprised of polarizer and LED. So it can operate on visible light and also infrared. And the other side is ANT, which is sensing module and receiver. So it is comprised of polarizer and photodiodes. So the ANT, the receiver, if the receivers receive the signal from our POLA, it can calculate its 3D position and orientation in the real time. So this is advantages. So in the PRS, we unlike our RF signals, sites cannot be interfered, so non-interferable, and also non-cumulative. So we do real-time calculation on the chips and the sensing module. And the last one is works with single signals. So we do not use triangulation. For example, so the right side is the case of our usability. So it can provide accurate measurement even when only one infrastructure, this is POLA, signal arrives. So I prepared demonstration video. I'm sorry. Okay. Oh, I'm sorry. Yes, POLA, TX, and RX. So you can see the light source is deployed on the ceiling of our office. And you can see the RX, the sensing module, attached on the tank. So basic principle is polarizations. When the light goes through the polarizer, the light can be polarized. So, and also there are two polarizers. So the intensity on the photodiodes, it can be measured. It can affected by two polarized angles. That is basic principles. So we will show you the robotics demo. So right side in the rear video of our office, in the top view, right? And left side is the final result. So the green arrow means the heading of the tank. and the green dots and the real-time positioning result on the raw performance. So the final 3D positioning accuracy, I mean the 3D position accuracy is under 5 centimeters, so pretty high. And we also provide a heading position, I mean the orientation. So we provide 60UF result for the vehicles. For example, cars or automated guided vehicles in smart factory. If we apply very simple filter, for example, such as common filter, we can show you. It can show that very clean, and the line of the movement, the red things. A little bit slow, right? Okay. So we can do point-to-point navigation using our PLS. If you click the target position, you can follow the rear the rear line like that one. So we use light. So we have occlusion problems. So I'd like to show you some occlusion case. So this is stability test. So if we add some very strong lights, the sensor, it cannot be interfered because we use modulation and the other algorithms. Stable status. And if it occurs occlusion using our hands, it shows that very random position. But in the practice, we provide, this is occlusion status. So, and hijacking the robot, and if you escape the occlusion, you can show very accurate position. So it's very similar to GPS. So it can provide the reference point for vehicles. Okay, and this is the second video. So it means how to deploy our kit, how to deploy our sensor. In this video, we have four light source. This guy is doing some installation, our light source, and the four light source. And we attach our sensor to tank, remote control tank, and do wireless control. And there is a final result of the position under multiple light source. Okay, you guys can see this video on YouTube also. Okay, so the final performance is the features. So we can cover the 4 to 20 meters about goal, and the presence the positioning error is 6.3 centimeters, but our goal is under 5 centimeters and 2 centimeters. And we provide refresh rate and over than 60 hertz average. So we also provide XYZ 3D position and heading also, so 60UF. I'd like to give you the product market fit, so more especially mobility market and precise positioning. So this is identified market demand. So these kind of companies have visited us to solve those problems. The common point is to measure the correct position of robot cars in the indoor space. The first company, W, is one of the leading companies in indoor mapping, and iParking provide smart parking lot infrastructure. And the last one is one of the subsidiary in the Hyundai Motorscript. They want to make some self-driving features in the indoor space. This is first case our collaboration with those mobility industry players. So precise indoor positioning system for mobile industry. So if the cars or autonomous cars getting into the big indoor parking lot, it cannot receive the GPS signal. So it cannot recognize where it is in the global position. So we installed light source on the ceiling of the indoor space, and we installed the sensor. I mean, the ant in the dashboard or bonnet. It can recognize its strategic position in the real time. Yeah, second one is building a large scale indoor maps and precise positioning. So WO provide indoor map, and we provide localization sensor. So it can make some autonomous shopping cart or autonomous guide vehicles in the shopping malls or smart factory. Recently, Plurent is acquired by Solcar. So Solcar is one of the leading mobility platform companies. It's simply the Korean Uber. So founded 2011. So we do car sharing services and also ride hailing services, Tada. And Solcar owns 13K vehicles in Korea, so and the 5K parking zones and pretty high market share. So they want to do some optimization for mobile industry, and also they want to get some final result in the position in their space of the vehicles. So the main purpose of this deal was to add capabilities of embedded system for larger scale field management and indoor positioning for vehicles. At last, I'd like to talk about the market needs, current market needs about IoT solutions for larger scale field management. This is needs for larger scale field management. So there's a representative three things. First one is precise localization for a large amount of vehicles in urban environments. As you know, in the urban environments, there are lots of buildings, so GPS accuracy very low. So we need high-spec GPS devices or GPS accuracy enhancing algorithm with high-definition maps in urban environments. And also, we want to make some map matching algorithm in navigation to make some precise localization. And second one is automotive electric devices for car sharing. So simply, it is easy to use for various users. So we need to make some car sharing friendly center fascia in the car and adaptive control of the steering level or car shift level for driver behavior. And the third one is driver monitoring system with face recognition and a smoke detection sensor. These kind of IoT solution we need. And at last, in the smart parking lot with spatial intelligence. In the car in the indoor space, they cannot know the target parking zone. So we need to provide indoor navigation from the parking lot entrance to the selected parking zone. This is our market demand. So mobile industry and IoT is big issues. So we focus this area very strongly. So Solcar and Plurent, we want you. So if you have any kind of interest about this technology or industry, please do not hesitate to contact us. Yeah, thank you.